So in this reaction we're gonna learn about Hoffmann Bromamide reaction, and it may also known as Hoffmann rearrangement or Hoffmann degradation reaction. So here 1 degree amide reacts with Br2 in presence of potassium hydroxide and 1 degree amine is formed. So here why it is called degradation reaction? Because there is a degradation of that carbonyl group. In amide you get rid of this carbonyl group in presence of Br2KOH, which forms 1 degree amine. Here it is 1 degree amine is formed. So in presence of Br2KOH, in presence of Cl2KOH, in the reaction may occur, or if both of them could react each other and they form K plus and OBr minus, a disproportionation reaction could be there. So if that also mentioned, the reaction also could proceed by them. So let's look into its mechanism. So we know it is 1 degree amide. It is 1 degree amide. So when 1 degree amide, we have a lot of base in the solution. So then OH gonna take this hydrogen and this hydrogen gonna leave from here. Now again we get this negative charge ion, okay, this negative charge which is resonance stabilized by over here. That's why it is considered as a good acidic hydrogen. Now in presence of the negative charge, bromine has delta positive sign here and delta negative sign here. The bromine get partial charge over here. So when nitrogen attacks over here, there is a movement, there is a removal of that Br ion and nitrogen gonna form Br and hydrogen. So that is known as N-bromoamide. This is known as N-bromoamide. Now again we have another base, a lot of base we have. So we will see that. So we have another base that OH minus gonna take this hydrogen over here. And when this will take in this hydrogen here, this negative charge form here. Now again there is a negative charge on nitrogen. And now here when the bromine leaves, this negative charge, the lone pair on that nitrogen get backs towards this carbonyl group, and at the same moment this bond, the alkyl group, attaches over here on this nitrogen. So this together, all this is known as Wolff rearrangement. So there is a formation of isocyanate here. So the alkyl group migrates from the nitrogen as a bromide ion departs. The produced an isocyanate. Now in isocyanate, the hydroxide ion attacks over here, and there is a negative charge on nitrogen also. So there is a negative charge on nitrogen. When nitrogen attacks over here, the bond shifts back over here, and when the bond shifts back over here, there is again then and there is an intramolecular that hydrogen shifts over here, intramolecular acid base reaction over here. Now we have water in the solution. So the lone pair on the nitrogen attacks over that hydrogen part over here, and it deprotonates the water and generates a hydroxide ion. And the same moment the CO2 gas leaves over here. Now when CO2 gas leaves over here, there is a formation of 1 degree amine, CO2 and hydroxide ion, and they together react from HCO3 minus. Now if we see the characteristic of the reaction, we have 1 degree amide. 1 degree amide react with X mole of bromine and Y mole of potassium hydroxide, form 1 degree amine, KBr K2CO3. So here if you see 1 mole of Br and 4 mole of KOH are consumed in the reaction. If you see the whole reaction, you will find there is 1 mole of Br2 and 4 moles of KOH are consumed in the reaction. So migration of that group, alkyl group, is the rate determining step, because that is the slowest step. That is the slowest step, the Wolff rearrangement. And rate of Hoffmann bromide, if we talk about, if we are doing a Hoffmann bromide reaction over this molecule and over this molecule, so we will see where the reaction will be more. So we know all this reaction we have to remove this, and the rearrangement becomes more effective when there is a plus M group attached over here. So more the rounding tendency, more the rate of the reaction. So more the electron donating group, more will be the migrating aptitude, more will be the rate of Hoffmann Bromamide reaction. So either OCS3 show plus M effect, NO2 show minus M effect. So migration is intramolecular. We know migration all occur is intramolecular. So this molecule and this molecule over here, let's say, and together they are put it into Hoffmann bromide degradation. So we will see that this carbonyl groups remove, this carbonyl groups remove. It doesn't get affected by outer surrounding. Okay, so then the formation of this amine and this amine will form means we are putting the isotope and checking the rate of the reaction or the mechanism. So yeah, it is intramolecular, totally intramolecular. If we see second and tertiary amide will not undergo Hoffmann bromide reaction because the formation of alkyl isocyanate is not possible. If we see we have this second order and this third order Hoffmann bromide reaction. So in first order there is a formation of isocyanate, and with the attacking of hydroxide ion we can continue the reaction further. But where it is 2 degree amide and 3 degree amide, we cannot continue the reaction further. In case of 1 degree amide only, the reaction could be further proceeded. So in Hoffmann bromide reaction there is a retention in configuration. That is important. There is a retention in configuration because breaking of the bond and forming on the bomb are from the same side. So where there is a, if we see the mechanism over here, so here the bond is breaking and here the bond is forming. So R is still R. We haven't leave the R free. When the nitrogen leaves, you see that Wolff rearrangement, the configuration of alkyl group doesn't change because it is not getting free any time between. It is not having positive charge. It is not getting chance to be planar. What was the configuration? It still is the configuration. So here this is the reaction we are getting. Now we see, if we want to check like one more time its configuration. So we add an ethyl group and we want to proceed the reaction. Still we will getting the configuration is same. The amine group, NH2 group is still is the below the plane as compared to methyl group. So they will be opposite when the reaction is proceeding. That's all from the different example. We can see that the whatever the configuration of alkyl group, if it is optically active, will retain in the Hoffmann bromamide reaction.